Welcome to the C# design patterns step-by-step video tutorial. What are design patterns? When you learn a programming language, you only learn how to read other people's code, not to write them. Given a project, it is very difficult to come up with ideas about how to design your class files to look professional. So how do you learn to write programs? Design patterns is the writer's workshop for programmers. This video will show you for a given problem how to design your classes. Now there are many design patterns. In this video I have chosen the 16 most popular design patterns. Every programmer should know design patterns. This is the material that will take you from being a junior developer to a senior developer. Hope you will find this video tutorial enjoyable. First, let us take a look at the Singleton pattern. Now, what is a Singleton pattern? If we want a class to have only one object, then we will use the Singleton pattern. Now you may ask, why should we have only one object of a class? Let's take, for example, the printer driver. If you allow multiple objects of the printer driver created, what's going to happen is, imagine you click on File Print over here at PowerPoint, and then you open up Word and then click on File Print on Word. If an object of printer is created every time we click on File Print, what's going to happen is all these printer objects are going to try and get hold of the printer. So there may be a lock, or what's going to happen is in one page, the very first part is going to be PowerPoint and the next part is going to be Word. So to avoid these kind of confusions, certain classes like the logger, printer, we want only one object of the class to be created. So how do we solve that? In Visual Studio, let us create a new project. Let us select Visual C# and then Console Application .NET Framework. Give a name for this particular project and click on OK. I have created a project here called C# Design Patterns with a folder called com.singleton. Imagine I create a class called logger and I have another class called as test logger. Now you know that if we have a class, you can create multiple objects of this class. So we have here one object of logger, logger object 1 equal to new logger, and we have created another object of logger saying logger object 2 equal to new logger. So here you can see that we have created two logger objects. So if you have a class, you can create multiple objects of that particular class. But we want to prevent this. So how do we prevent it? You know that whenever we create the object, what is the first method that is called? By default, whenever we create an object, the constructor of that particular class is called. So the way we create objects is using the constructor. Now you may know that every class, even if you did not write it, has an inbuilt constructor. So even though you cannot see it to the naked eye, every class has this particular code called a default constructor. A constructor is a method that has the same name as the class. It has no return type. So whenever we create an object, this constructor is called. Without the constructor, you cannot create objects. So what we are going to do is, we are going to make this particular constructor private. So once you make this particular constructor private, what's going to happen is, no other classes can create objects of that class. So you can see that we are unable to create objects of logger because it is not able to access the constructor. And without the constructor, you cannot build objects. But this doesn't solve our problem. We still want to be able to create one object. But by making the constructor private, we are not able to create any objects. So how do we solve it? The suggestion of design patterns is, create an instance of logger right here inside this class. So we are creating an instance of logger right here, and we are going to have some kind of a getInstance method. You can call this method any name. We are just going to call this method getInstance. What this getInstance method must do is, it should check if this particular logger object is null. If it is null, then let us create a new logger object and return it. If it is not null, then return the same logger object again and again. It goes something like this. If logger equal to null, if logger equal to null, then create a new object of logger. Then create a new object of logger and assign it to this logger. Now you know that within this particular class, it can access the constructor. Because the constructor is private, that means it is visible to this class alone. You can create a new object of logger and assign it to this logger. So you can access the constructor within the class. Now if the object is not equal to null, that means a new logger object had already been created. You simply have to return it. You simply have to return it. Since you're returning a logger, you create this particular logger object right here. So what exactly is happening right here? The getInstance method will check if this logger object exists. If it already exists, if it is not equal to null, it will simply return that logger object. If it is equal to null, then it will create a new logger object, assign it right here and return it. So if it already exists, it will simply return it. If it is equal to null, it will create a new logger object and return it. Now let's use this. But here is the problem. To call that getInstance method, I still need to create an object. Remember, you cannot call a method without creating objects of that particular class. So if you think about it, how else can we call a method in a class without creating an object? Remember, you can call a method in a class without creating an object if it is a static method, because static is one per class and not one per object. So if you say that this getInstance method is static, that means you don't need objects of this particular class to call this particular method. And static also comes with a rule. The rule with static is static methods can only call other static methods or data. So it is complaining, hey, you have a static method, but then you're trying to call an instance object or non-static object. So all we have to do is put the static over here too. So this solves the problem. So by making this static method can access this particular logger instance, a static logger instance. Now let's go back to test logger. So instead of creating objects like this, we can say logger.getInstance. Logger.getInstance. So what's going to happen is this. The very first time logger calls the getInstance method, it is going to come here. The very first time logger calls the getInstance method, it's going to come here. It is going to check if this particular logger is equal to null. Of course, it is going to be null because we never instantiated it. So what it will do is it will assign a new logger object to this particular logger. So this logger will now be instantiated. Once it has been assigned, it will simply return this particular logger object. So we got that new logger object right here. The next time it calls logger.getInstance, it's going to come here. It's going to check if this particular logger is null. No, it is not null because we just instantiated that particular logger and assigned to it. So it's not going to be null. So it's going to skip this code and it's going to return the same logger. So you're going to have the same object returned again and again. Now how can we prove this? If we print out the hash code of both the objects, you will notice that they will be the same. Let's run this debug start without debugging. And here you can see that the hash code is the same. That means both the objects are the same. If you try to create multiple objects of another class and get their hash code, they're going to be different. I can prove it by creating another class right here. So I have a class test. So I have created a class test, and here you can see that I created new test objects, object 3 and object 4, and we are getting the hash code of object 3 and object 4. This is the non-singleton, and over here we have the singleton. You will see that the singleton classes will have the same hash code and the non-singleton classes will have different hash codes. So the singleton objects same hash code, which denotes that they are the same objects, whereas the non-singleton have different hash codes. So what is a singleton pattern? If we want only one object of a class and we want to reuse the same object again and again, then it's called the singleton pattern. How do we program that? We program that by making the constructor of that particular class private and having a getInstance method which will check if the instance of that particular object is already there. If it is already there, it will simply return it. If it is not there, it will create a new object and return it. But how do we gain access to this particular method? We gain access to this particular method by making it static, because once you prevent objects from being created, then there is no way to access methods in those particular class. So we make this particular method static, and since static methods can only call other static methods or data, then we have to make this instance also static. And for creating objects, you simply have to say the class name dot getInstance method and it will return that object. If it is not there, it will create one and return it. What is the advantage of the singleton pattern? Singleton pattern is used for logging purposes, device drivers, registry settings, when we don't want multiple objects, because multiple objects is going to create logs or is going to have issues. Then we will use the singleton pattern. Now in C#, they may express the same code using a different syntax. Instead of saying logger over here, they may call it instance. And over here, instead of having a getInstance method, they may express the getter and setter like this. You know that this is another way to express the getter method in C#. If the instance equal to null, if this instance is equal to null, then create a new logger object and return it. If it is not null, then return that particular logger object. In C#, you can write your getters and setters like this. You can either write a getInstance method like this, or you can write the same thing, a get method like this. And here, instead of calling the getInstance method, you are calling the instance. So what does this do? Logger.instance is going to call the get method because we are going to get something to instantiate this particular object. So this logger.instance is going to trigger this instance and it's going to come and call the get method. It is going to call the get method because we are going to use it to assign some object. It's going to trigger the get method. And it's going to come here and it's going to check if this instance is null, then create a new logger object and return it. If it is not null, then return the same object. If you run this, there is going to be no difference. You can see that the hash code is the same. So this is the C# way of doing it, but both of them are correct. Now, before looking at the next design pattern, let us look at some of the basic concepts you should know. I'm going to exclude these two classes and I'm going to create a class called say A. Now imagine we have a class A and a class B which inherits from A. Let us create a test class with the static void main method. In C#, one file can have multiple classes. So you know that we can create objects of A like this. A object equal to new A. You also know that you can create objects of B like this. Can we create objects like this? A object equal to new B? Yes, you can. Because Remember, you can always create objects like superclass object equal to new subclass. But can we do the reverse, that is B object equal to new A? You cannot do this. You cannot say subclass object equal to new superclass. Now, when we say A object equal to new B, is this an A object or a B object? To understand that, let us look at the syntax. Integer x equal to 10. Now, what is the value of x? The value of x is 10. So if you take a look at this integer x equal to 10, you notice that the value of x equal to 10. Same way, when we say object 1 equal to new b, the value of object 1 is b. So that means this is a b object. So whatever is on the right hand side gives the value of this object, and this is a b object. Now how do I prove that this is a b object? Imagine this class A has a method A which prints out AMA to denote class A method A, and class B has a method B which prints out B method B. Objects of A can only access methods in A. You can see that objects of A can only access methods in A. Objects of B can access both methods of A and B because it inherits from A. B object can access both methods A and B. Now let's take a look at this. This one, I said it's a B object, but then it can only access method A. So you may be wondering, like, why did you call this a B object even though it can only access methods in A? So let's run this. Well, everything executes as expected. Now to prove that this is a B object, I have some print statements to differentiate the various printouts. This will print out A object methods, B object methods, and A or B. We are trying to figure out if this is an A object or B object. So I am claiming that this is a B object, and I want to prove that this is an object of B. The way we can do that is, imagine we have this particular method A as a virtual method, and we have another method A right here which overrides that virtual method. So this class A method A is a virtual method, and class B, which inherits from A, overrides that particular method A. I'm going to denote it as BMA right here. So this is AMA, and this one prints out BMA. Now, when we call A objects method A, it will call the virtual method A. It will call the class A's method A. When B object calls method A, it will call the overridden method A. Because it is a B object, it will call the methods in B. Now, if this had been an A object, then this particular method A should call this method A in class A. But you will notice that when we say superclass object equal to new subclass, what it will do is, since the right hand side says it is B, this will be a B object, and thereby it will behave like the B object and call the method A in class B. You can see that the last line, it actually calls the method A in class B, thereby proving it is a B object and not an A object. So you may ask, like, if this is a B object, why cannot I call method B? The reason for that is, let us look at this line again. The value of x is 10. That means it can accept any integer, but the property of x is an integer. What it means is it can only accept an integer. Same way, the value of this particular object is B. We proved that this is a B object by calling the method A, and it executed the method in B. But the property of this object is A. That means it can only act like this particular class A. Class A does not have a method B, so it is unable to call this method B. But still, this will act like the B object. It can act as long as A has those methods. This A need not actually be a class. It can also be an interface. Imagine we have interface IA. we have converted this class A into interface IA with the method A, and this B implements IA. It's the same concept. You can no longer create objects of A, but you can create objects of B, but you can use the same concept here and say like IA object equal to new B. So this is actually a B object. You cannot create objects of an interface, but you can specify that this is a B object. It still cannot call method B because the interface does not have a method B. If the interface had a method B, that means if the interface had a property called method B, then it would be able to access it. But is it calling the superclasses method B? No, it is calling the implementation. That is, the right-hand side provides the value. The left-hand side provides the behavior or the property. So just remember this concept. When you say superclass object equal to new subclass, the object is that of the subclass, because the value of this is what is on the right hand side, just like integer x equal to 23. X value is 23, but the property of x is on the left hand side, that is integer. It can only do what an integer can do. Same way, when you have an interface, this object value is on the right hand side, but it can only behave within the constraints of the interface. Of course, going back to the example of having a class A and class B inheriting from A, when you create objects using this particular syntax, superclass object equal to new subclass, you can access the methods in B by casting. When we say object 1, it is not able to access method B, but if we cast that particular object, now you will notice that you are able to access method B. You can either cast it like this or using the as keyword. So if you create objects of superclass object equal to new subclass, by default it can only access the properties in this superclass, but you can access the subclass properties by casting it either using the parenthesis or using the as keyword. The next basic concept I want to talk about is, when you have a class, say employee, with all these properties, what are the different ways we can set the values for these properties, and when would you use each? You know that there are 3 ways to set the values for these properties. You can either hardcode them right here, or you can use a constructor, or you can use a setter method. But when would you use each? Now, to understand when to use a constructor or when to use a setter or when to hardcode the values, let us take a look at a table. So here we have an employee table which has an employee ID, employee name, salary, grade and company, and it has some records. Now you know that you can translate a table into a class. The table name becomes the class name, and the column names in the table become the properties of the table or fields of the table. We have columns called employee ID, name, salary, grade and company. So we have the employee ID, name, salary, grade and company right here. Now objects are nothing but records of that particular table. This particular record will be one object. So when you say something like 100 Alex, 100K and 5 and company name is IBM, when we create an employee object, we can say object dot, imagine they are all public. You can say object dot employee ID equal to 100, object dot employee name equal to Alex, and so on. But when would you use a constructor and when would you use a setter and so on? Let's take a look at the table. Imagine you want to create a third record. If you create a record like this, what you are doing is you are creating a record with no values. In a table, would you create a record with no values? No, you will say that like, hey, at the minimum, when I create a record in a table, I should have the employee ID and employee name. At the minimum, I should need these 2 values. The salary and grade will keep changing later on. The person's salary may be updated, the grade may be updated. But at the minimum, Whenever I create an employee record, I want the ID and name to be there. Their join date may change, like they may join this week or next week. So all these things can change. But what are the absolutely required values to create a record? Even if you feel like, what if the person changes the employee name later on, they put in a different last name, but I need an employee ID created. So you have to decide, when I create a record, what are the absolutely required values that I need to create a record, without which I cannot create a record right here. So those things must be in the constructor. So in this case, we feel like the employee ID and employee name should be absolutely required, or at least the employee ID should be absolutely required. The person's name may change, the salary may change, the grade may change, but I need the employee ID, without which I should not be able to create any record. Prevent anyone from creating objects of employee or records of employee without giving the employee ID. So in those cases, we must create a constructor which takes in the absolutely minimum required values. So here you can see that we are insisting that we get the employee ID and employee name, and we are preventing objects to be created without these two values. So now you cannot create objects without giving the employee ID and name. So use a constructor when you feel you should not have objects without certain basic values, certain required values. If you can imagine your class file as a table, would you create a record with no values? No, you will have some values set there before creating a record. So think about those values and make sure they are there in the constructor. That is, without those values, there should be no record or no object. So that is the reason why you would use a constructor to set certain values. When would you hardcode the value? If you feel that every object that is created will have the same values. All employees of this company are going to have the company name as IBM or some other company name. I'm just using IBM. Then you can hardcode that particular value right here. That means whenever a person creates a record, the company name by default will be filled as, say, IBM. This video is nowhere related to IBM. I'm just using it as an example. So when would you use setter? You will use the setter whenever you feel that the values can change frequently. For example, the salary will keep changing frequently, the grade will change frequently, or for that matter, these are not very important values. These values can be entered later. They are not absolutely required to create an object. So those things can be in setters. So we can make the employee ID and name as private, or if you feel the name may change in future, you can keep it public. But the salary and grade, I'm going to create getters and setters. So this means it can be updated anytime. The grade and salary can be updated anytime. They are not absolutely required and they may change frequently. So once again, use constructors if you feel certain records or objects should not be created without certain basic values. They should go into the constructors. Setters, frequently changing values or values that are not important that can be set later, they should go into setters. And if all objects have the same value, those should go as hard-coded values right here. Let's expand on this example a bit more. Imagine you have an interface called iEmail. And this iEmail has a method called sendEmail, an empty method, abstract method called sendEmail. And imagine this particular employee class as an instance of iEmail right here, because we should be able to email the employees. We are not setting any values for this iEmail. We are simply creating an instance of it. Of course, we cannot create objects of an interface. But remember, you can create superclass object equal to new subclass. That means we can create a subclass object later on and insert it right here. We are doing something like this. We are first declaring this particular object 1 as IA, and then we will be assigning values of object 1 equal to new B. Instead of writing it in one line, we will be doing it in 2 lines. It's the same concept right here. We are simply creating an instance right here, but we are not assigning any object to it. Imagine here we have a method called notify email. This notify employee method calls the email object send email. So this notify employee calls the email object send email. We have written this, everything compiles fine. And imagine we are going to call the notify employee method. We are calling the notify employee method of this email object. Now everything compiles fine, but when we run this, it's going to throw an exception. You see the exception? System.null reference exception. Object reference not set to an instance of an object. That means it's saying that, hey, when you call notify employee, it is calling an email object send email, but you haven't set what the email object should be. What is the implementation of the email object? What is the right hand side of it? What is the value of the email object? You haven't specified that. So in those cases too, if you are going to make use of this email object in your code, there is a risk that people may call that method without making sure that this object has been implemented somewhere. So this is also a great candidate to be in the constructor. That means make sure that when a person creates an employee object, if there is a dependency between the employee object and some other object, that means they have to be set. Otherwise, there is a risk of runtime exceptions. Without setting the value, someone may call the notify employee and this is going to blow up. So this is another candidate for a constructor. So we are going to pass this value, this dot email equal to email. How do we pass the email object? We don't have any implementations. You cannot create an object of an interface, so you need to have an implementation of iEmail, like say Outlook email or web service email, or you can have multiple implementations of it. So let's create 2 implementations of iEmail. So here Outlook email implements iEmail and the send email method will print out send Outlook email. Let's have another implementation. So here you can see another implementation of iEmail, that is web service email, which will print out send web service email. Now to create an employee object, you need the employee ID, absolutely required, the name, as well as it needs some object of iEmail, some implementation of iEmail to be passed in. So we can say the same concept, superclass object equal to new subclass. iEmail, we can say new Outlook email, and we can pass in the Outlook email object. And for Linda, we can reassign the same iEmail. We can reuse this iEmail right here, email equal to new web service email. And we can pass in that implementation right here. So when you send an email object, so this email object value is an Outlook email object, and this email object's value is a web service email object. So you're going to pass them right here. It's going to come and set the email object, this email object, to Outlook email for Alex, and it's going to set for Linda's object, it's going to set it as a web service email. Now when we call object.notify, for Alex and object3.notify for Linda, the first time the Outlook email method will be executed, and the second time the web service email method would be executed. Outlook email, web service email. We are looking at the same concept right here. When you have a superclass equal to subclass, it is actually a subclass object, and depending on whichever subclass it is, it will act like that particular subclass. It can only access methods that are part of the superclass, because just like integer x equal to 23, x value is 23, but the property of x is an integer, this particular object can call the methods that are defined in the superclass, but they will actually call the methods of the subclass because the right hand side provides the value. So we have learned when to use the constructor, a constructor, should be used whenever you feel that an object should not exist without certain basic values. In this case, employee ID and employee name. Not only that, since there is a dependency of employee object, or there is a risk of this employee object calling methods, and they may have runtime exceptions if certain values are not set, all those have to go into the constructor. If you feel a value keeps changing frequently, or if you feel like certain values are not absolutely required to create an object, those can have setters. If you feel every object will have the same value, every record will have the same value, they can be hard coded right here. So this is how you differentiate when to use hard coded value, when to use a constructor, and when to use setters. Next, let us look at the concept of factory pattern. The factory pattern advises that if you want to create an object in your application, do not go around creating those objects anywhere you want, but have a separate place to create these objects. Just like a shoe factory manufactures shoes and a car factory manufactures cars, every application should have a separate place to create these objects. The advantage of having a separate place to create these objects is you can control in one place how these objects are created. For example, let me exclude these two files. If you want to still see them, you can always click on Show All Files right here in Visual Studio and create a new folder called com.factory. Now imagine you want to write a program to divide two numbers. If you do not use any patterns, you are likely to do something like this. We will create a class called, say, divide, and in this you are likely to have a method like, say, calculate divide and print out the answer. So here we have the calculate method which takes in two numbers and prints out a divided by b is, in the 0 index, print out a divided by b. So you're likely to do something like this. Maybe we'll make it a double number. So to divide two numbers, you may create a class, write a method called calculate, take in two numbers, and then you're going to print out the answer of those two numbers. And in a test method, you're likely to input two numbers, and in the test class main method, you're likely to input two numbers, like here, we are printing out enter first number, reading from the console. And then what we are doing here is we are trying to convert that particular string. Whatever is entered in the console goes into string input. We are trying to convert it into a double number using double.try parse. You remember that when we use double.try parse, it will try to convert this particular string into a double number. If it is successfully able to do it, then it will return true and give out the number that has been converted in out number. So if you enter a wrong number, what's going to happen is it's going to be false. Not of false is true. So they will once again ask for a number. If everything is correct, it will ask for the second number, and you're doing the same thing. And then you're likely to create an object of divide and call the calculate method in divide, pass two numbers, and it will print out the answer. Let's run this. Enter first number. A divided by b is 2.5. So if you do not use patterns, this is how you're likely to do it. What design pattern says is, the very first rule of design patterns is always program to an interface. The first and basic rule about design patterns is always program to an interface. What it means is you should never have classes just like that and have methods in them. All classes must inherit or implement some kind of an interface. That makes your application flexible. Always program to an interface. So let's change this. What we will do is we will create, let's say, an interface called iCalculate. So we are creating an interface called iCalculate. And in this interface, let us have a method called calculate, which takes in two numbers. Now we will go back to divide and we'll implement that interface. So divide implements iCalculate. iCalculate has a calculate method. and that has been implemented here already. So you may be wondering like, okay, what has changed now? The advantage now is this program has become flexible. Now we can have multiple implementations of this interface. You can see right here, you're going to have like a calculate interface, and then you can have multiple implementations of it, like add, divide, subtract. So let's create those subclasses which implement this interface. So I'm going to create an add class, a subtract class. I can just copy paste it from here and change the code. So add implements iCalculate, and subtract implements iCalculate. So now we have three classes: add, which adds these numbers, it implements iCalculate; subtract, which subtracts these numbers, which implements iCalculate; and divide divides these numbers. Now we will create a separate factory class. The idea behind the factory class is it will decide what object to create based on some kind of a parameter. So let's create a class called, say, calculate factory. And in this calculate factory, make sure your classes are public. I wish Visual Studio by default puts this word public right here whenever we create these classes. And in this calculate factory, let us create a method called, say, get calculation. This method will take in some parameter based on which it will decide what object to create. Let's say string type. But what do we want this method to return? We want this method to return one of the calculate objects. We have three calculate objects: subtract, divide, and add. We want to return one of these objects. So what is the common return type for all of them? It is this interface called calculate. Remember the concept? You can always have an instance of interface and then you can assign them a subclass. So to this superclass object, you can assign any one of these subclasses. You can either assign the add object or subtract object or the divide object. As long as the subclasses implement the superclass or extend the superclass, we should be able to assign them. To this IA, we will be able to assign new B as long as B implements IA. So using that concept, we will say this one returns some kind of an implementation of iCalculate. So here, let us create an instance of iCalculate. Of course, you cannot create objects of an interface. We'll have to assign the values later on. We'll denote it as null for now because it is inside a method. Because it is inside a method, you're always supposed to give some kind of a default value. So we will give something like a null. And then we will check what type of object do they request from us. So as saying, whatever the type that is coming in, we will convert it to a lowercase .toLower method, an inbuilt method. And if it is equal to add, we will create a new add object. We will create a new add object and we will return that add object. And we will assign that add object to this iCalculate object and we will return that later. So here we are creating a new add object and we are assigning it to iCalculate object. Superclass object equal to new subclass. The superclass can be anything. It can be an regular class, it can be an interface, or it can be an abstract class. So now we have a bunch of else if statements. We are going to check if it is subtract, create a subtract object and assign it to this object. If it is divide, create a divide object and assign it to this object. Else if everything fails, we will simply print out we don't do that. If you want, you can also throw an exception. And in the very end, we will return this particular object. It's complaining about accessibility when I compile it. That's because of not making them public. So make sure your classes interfaces, all of them are public. So here you can see that the calculate factory has a get calculation method which takes in some kind of a string. The string will have the request about what kind of object it wants. And the logic here will decide to create an object of either add or subtract or divide based on this request. All these objects can be plugged into this iCalculate object because we learned that concept. You can create objects like Superclass Object equal to new subclass. The superclass can be an interface. So this is the common syntax that can hold objects of all of the subclasses. And once we have created the object that is requested, we can return that particular object like this. Now once we have created this calculate factory, let's go back to the test method. And here we'll create an instance of this calculate factory and request what kind of object they require. We'll have a print statement, enter, add, subtract or divide. We'll create an object of calculate factory. And we will call this factory dot get calculation method. We'll call the factory dot get calculation method and we'll pass in the read line. So what's going to happen is this factory object is going to call the get calculation method and it's going to pass in whatever is typed into the read line, and after which it's going to create a new object based on whatever we type in, and it's going to return one of these objects, add, subtract or divide. All of them are of type iCalculate. So here we are going to receive that iCalculate. We no longer need this divide object. So based on a requirement, based on whatever you type in, you're going to receive either an add or subtract or divide. But if you remember, I told you the value of this object will be based on what is on the right hand side. So if an add object is sent in, it will be an add object. If a subtract object is sent in, it will be a subtract object. And when you say object.calculate, it depends on what was sent in. If an add object was sent in and you call an object.calculate, it will call the add methods calculate. And it will add these two numbers and print out these values. So let's run this. You can see that it is printing a plus b is 5. If you want, we can make it run it again and again by calling the main method again. And it goes for an endless loop. So now you understand the concept of factory pattern. Factory pattern recommends that if you're going to create an object, do not create it all over your application. Have a separate place in your project whose only job, that folder's job, will have classes, various factories whose only job will be like to request some kind of an input, and then based on that input, it will create the objects that you want. The advantage of having all the logic for creation of object in a separate places, if ever you decide to change your application, the way you want to create objects, like maybe you want to have a constructor, hey, do not create an add object without getting at least 2 numbers. Do not create a divide object which takes a second number as 0. So if you want to change any one of those business logic, you will have all those logics in one separate place. So that's the advantage of the factory pattern. And when you follow this rule of always program to an interface, it makes the program so much more flexible. if you want to add like a multiply, all you have to do is create a multiply class which implements iCalculate, and over here in the factory class you can add some more logic to create multiply objects. So this completes the factory pattern. Factory pattern is simple but also the most popular pattern. Make sure that in all your future projects you use a factory pattern to create objects. Next, let us look at the template method pattern. Template method pattern states that subclasses decide how to implement steps in an algorithm. Let's see what it means. Imagine I have a class which processes Excel files. Let me call this Excel file. Imagine in this class we have three methods: a method to read Excel file, a method to process the Excel file, and a method to save the Excel file in the database. So here you can see in the class Excel file I have three methods, one to read data, another to process data, and another to save data. I'm not going to write code in these three methods. I'm just going to have some console.writeLine, assuming there is code to read data from an Excel file and process data from an Excel file in these methods. So in this read data method, if you run this particular method, it's going to say reads data from Excel file. So here you have all the three methods. This one reads data from Excel file, and here there is code to process data from Excel file. The save data simply saves whatever the data to the database. So let's test this class. I'm going to call it test template method. I'm going to create an object of Excel file, and I'm going to call all the three methods in that particular order. So here you can see that it's calling the three methods read data, process data, and save data. Let's run this. Debug start without debugging. Here you can see the printout reads data from Excel file, process data from Excel file, saves data to DB. Now imagine we have another program which reads data from a text file, processes data from a text file, and saves it to the DB. Let's create a class called text file, and this class called text file is going to have those same three methods. So here you can see that it's going to read data from a text file, process data from a text file, but for save data, since all the data is going into the database, I'm going to leave it as saves data to database. Now let us create an object of text file and call these three methods. I'm going to name these as object2. And when we run this, you can see that the very first three outputs are for Excel file and the last three outputs are for the text file. Now imagine I want to maintain some kind of an order right here. Now if I'm going to give these class files to another programmer to use, there is always this risk that they may call this process data first and then the read data and then the save data, or they may first try to call the save data and then the read data and then the process data. You can see that there can be all kinds of issues. Maybe I want to make sure that this order is maintained. So let us create a method which calls these three methods one after another. So in this Excel file, maybe we can create a new method called, say, read, process, and save data, which calls all these three methods in the right order. So let's create another method, which then is going to call these three methods one after another. Read data, process data, save data. I'm going to put void right here. We can use the same method for text file too, read, process, and save data, which is going to call the read data, process data, and save data. Now, instead of calling all the three methods one after another, we can comment these out and just call object.read, process, and save. Makes it easier. If I run this particular program, you can see that read data from Excel and here that is read data from text file. It's the same thing, but we have simplified how we are calling those methods. We want to make sure they maintain the order. Now in programming, if you have methods, you should not repeat those methods across various classes. For example, let's look at the methods in Excel file and text file. The read data method of Excel file is different from the read data method of the text file. Here, read data method of text file reads data, will have code to read data from a text file, whereas the read data method of the Excel file will have code to read data from an Excel file. But methods like read, process, and save, the code is exactly the same for both the Excel file and the text file. It calls read data, process data, and save data. Same way, I'm assuming that the saved data saves to the same database. So the code for saved data in Excel file is going to be exactly the same for code for the saved data in the text file. If you have the same methods, an efficient way of programming is putting them in the superclass so that the subclass method can share those same methods. So let's create a general superclass for this text file and Excel file. I'm going to create a new class and let's call it data processor. In this data processor, I want to put the common methods in the text file and Excel file right here. So that common method in text file and Excel file is read, process and save data. And the common method for Excel file and text file is the save data. There will be errors, let's ignore them for now. So now that we have the common methods in the superclass, let's go about deleting these two methods. Both in the text file, I'm going to delete the read, process and save data, and I'm going to delete the save data method in the text file as well as in the Excel file. I'm going to delete it in the Excel file too. Now that I have deleted the methods from Excel and text file, I'm going to leave only the read data method and process data method in the Excel file and the read and process data method in the text file. Since we have the common methods in the superclass, I'm going to inherit the data processor. I'm going to inherit the data processor in the Excel file and text file so that these two methods will be there. So in the text file, I'm going to say inherit from data processor, extend data processor, and Excel file inherit data processor. It is complaining that the data processor is less accessible. So let's go make this public. And let's keep this also public. So now text file has these two methods, read, process and save, as well as save data, and Excel also has these methods because it inherits those public methods. Now let's look at the errors right here. Now this read, process and save data method is complaining that it is unable to find the read data and process data, which is true. You need to understand text file inherits from data processor, so it knows the methods in the data processor. But data processor does not know about text file. It is trying to call a method called read data and process data in the text file or an Excel file, but it has no idea about those methods. So how do we go about solving this? If you think back about the C# concepts, what concept do you think is going to help us solve this problem? If you have guessed abstract methods, that is correct. Now this data processor class has no idea about read data and process data. But for this method to compile, we have to create some kind of a placeholder saying that, hey, imagine that read data method is defined. I'm going to define it later on, but imagine it's defined. Go ahead and compile. So how do we do that? We have to make sure that we are defining it as an abstract method. So I'm going to say public abstract read data. Of course, this read data returns void. So here you can see that that error has gone away. We are going to do the same thing for process data, and these errors have gone away. The errors that are produced here are, it says read data is abstract, but it is contained in a non-abstract class. We remember the rule, if a class has abstract methods, that class has to be called as abstract. So I'm going to name this class as abstract. It's just a rule in C# and in Java. Only abstract classes can contain abstract methods. So now you can see that all the errors have gone away. What does this mean? We are telling read, process and save data. We are telling this class, we are telling this method, hey, do not worry about the read data, do not worry about the process data. We are going to define it later on. This is just going to be an abstract class, so no one is going to create objects of abstract classes. So this will be defined later on. The actual definition takes place in the subclasses. You can see that over here, the text file defines read data and process data. The errors right here are because we used abstract methods in data processor and we are using the same methods in the subclass. So when you have the same method in the subclass as in the superclass, you have to use the override keyword. So if you put this override keyword, the errors will go away. It's the same thing with the Excel file too. So let's go test this out. We'll go run this. You can see that there is no difference in the output from our previous program. So what exactly did we do? Let's look at the definition again. Template method pattern. Subclasses decide how to implement steps in an algorithm. I just showed you the evolution of the algorithm. So our algorithm is this read, process, and save data. We have 3 steps in this algorithm: read data, process data, and save data. Since save data is going to be the same across different processes, I have coded the save data over here. But for the read and process data, we have made them as abstract methods because the steps are going to be how to implement this read and process data is going to be different for different processes. For text file, it's going to have a different implementation. For the Excel file, it's going to have a different implementation. Subclasses decide how to implement steps in an algorithm. So template method pattern is also an excellent example as how abstract methods and abstract classes came into being. What are the real actual uses of them? Also, since we are using inheritance, instead of using Excel file object equal to new Excel file, we can always use the superclass object equal to new subclass. We have read this before. Data processor object equal to new Excel file. So this is the template method pattern.